A projectile launched from the ground landed a horizontal distance of 120 meters from its launch point. The projectile was in the air for a time of 4 seconds. If the projectile landed at the same vertical position from which it was launched, what was the launch speed of the projectile? Ignore air resistance. Alright, so we have a projectile being launched probably at some angle like this, and it goes up, meets its kind of peak, and then falls back down at the same height that it was launched from. Okay, so what this essentially means that is the distance it travels in the y direction is 0. Even though technically it travels up and then back down, its total displacement at the end is 0. Okay, the other things that we can kind of gather from this is that its time in the air is 4 seconds, and the acceleration due to gravity is negative 9.8 meters per second squared. Now the written solution for this one uses a different method, so I'm going to use both methods here, and you can use whatever one you pick. But I think this one is a bit more intuitive just because for all the previous problems when we're measuring kind of projectiles in the air, we've been using this particular method I'll show you right now. So normally, at least I'm inclined to use this formula right here, d equals VOT plus 1/2 AT squared. And we can use this because we have t, we have a, again we have t, and we know the distance traveled is 0. So the only unknown is VO, and we can solve for that. So we have 0 equals 4 VO plus 1/2 times negative 9.8, and then t squared is 4, so 4 squared. Okay? So to solve for VO, I'm going to move this whole term over to the left, which will make it negative, and then that will cancel out this negative. So if you're wondering where those negatives went, it's because they cancel out. So we'll have 9.8, 1/2 9.8 times 4 squared. I'll just do that calculation now, is 16, and that's going to be equal to 4 VO. And then we just divide over by 4, so this becomes 1 over 8, 9.8, 16. Okay, so if you just want to plug that into a calculator, you will get 9.8 times 16, 19.6. And so this is VOY. It's important that we note that because we're using the acceleration in the y direction, and we're using the distance in the y direction. So that's just our VOY, our initial velocity in the y direction. But we need to find the speed of the projectile. So we're going to need to find the magnitude of not only the y, but also the x. Luckily for us, the x is a lot more easy to find because there's no acceleration in the x. And they've given us the horizontal distance and the time it spends in the air. So Vx is just going to be equal to the distance it travels in the x divided by t, which is 120 divided by 4, and that's 30 meters per second. Okay, so if we want to find the speed, which I'll just call v, v is going to be v squared is going to be equal to VOY squared plus VOX squared, all, and then we root both sides. Okay, so that's going to give us 19.6 squared plus 30 squared, all rooted. And if we just punch that into our calculator here, we have 35.8 meters per second.